So, solving quadratic equations by graphing. So if you look right here, this is the quadratic equation. This is when the y value is equal to 0. We learned in 11.1 that it's ax squared plus bx plus c equals y. This is the actual equation, but this is right here, this is when the y value is equal to 0. Okay, the roots, zeros, and x-intercepts are the exact same thing. So if I look at this, there are 3 types of solutions you could have, or equations you should have. You have some that have 2 real solutions, 1 real solution, or none. It doesn't touch at all. Double root is when the vertex is on the x-axis right there. That's a double root. What does that mean? It means that I should not write in y equals x plus some number squared. Okay, so we're going to come down here and we're going to solve this. Now, for right now, we're going to change this to y. It'll make it easier to do this problem. So x is equal to negative b over 2a. So x equals negative b, so negative 4 over 2a. So that'll get me negative 4 over negative 2, so that means x is equal to 2. So then, in order to find the vertex, I already know x is 2, I need to find the y value. So negative times 2 squared plus 4 times 2 plus 5 is going to equal y. So that's going to get me negative 4 plus 8 plus 5 equals y. So this is 4 plus 5, so that is 9. Then my y-intercept. Y-intercept means that the x value is 0. If I plug in 0, 0, that's going to get me a 5. So 0, 5. So those are the numbers we have so far for x and y. Our vertex is the middle one, so that's 2, 9. And I can even plot 2, 9. That's my vertex point. Then I have my y-intercept, which is 0, 5. 0, 5. Now, we have a 1 here, we have a 3 here, but remember the 4 is also going to be 5 because it's symmetric. Remember that this is symmetric. Oh, did I do the wrong color? I did. Okay, this is the axis of symmetry. So if I was to plug in 1 into this equation, I would get negative 1 squared plus 4 times 1 plus 5 equals y. That would get me negative 1 plus 4 plus 5, and that would get me 8. So this is 8 and this is 8. So now I'm going to plot these points, 1, 8 and 3, 8. Then I'm going to do 0, 5, 0, 5, and 4, 5. And there we have it. So now, there we go. Okay, so let's come over here. The axis of symmetry, x equals negative b over 2a. So my b value is 5, 2 times 1. So, some of you are having a hard time with this one. That's going to get negative 2.5. Okay, so my vertex is negative 2.5, comma, and we have to find that out. So negative 2.5 squared plus 5 times negative 2.5, plus 6, I'm trying to fit it in, equals y. So this is going to be, let's see, 6.25 minus 1, 12.5 plus 6 equals y. So this is going to get me 12.25 minus 12.5 equals y. So that's going to get me negative 0.25 is equal to y. Okay. I have no idea why we have this graph for. Okay, so y-intercept. If I was to plug in 0, remember we're pretending this 0, 0, that would get me a 6. So 0, 6. Not sure why we are using one that doesn't have. But that's okay. So negative 2.5, negative 2.5, and here. Oh, nope, it's below the line. Okay, and then 0, 6, I don't know. Negative 2.5 is in the middle, and that's negative 0.25. So we're going to do negative 3, negative 4, negative 2, negative 1, 0. 1, 2, 3, negative 5. So 0 is 6, so that means negative 5 is also 6. Okay, so if I was to put in negative 1, so negative 1 squared plus 5 times negative 1 plus 6 equals y. So that's 1 minus 5 plus 6 equals y. So it'd be 7 minus 5 equals y. So that's 2. So that means those are 2. So negative 1, 2. And negative 4, 2. Okay, so now I'm going to put in negative 2. Why do I keep using red? So negative 2 squared plus 5 times negative 2 plus 6 equals y. So that's going to get me 4 minus 10 plus 6 equals y. Isn't that 0? So these are both 0. So at negative 3 it's 0, and at negative 2 it's 0. There we go. Okay. And now we're going to come down to this one. Oh, but everything has to be on the same side of the equal sign for this to work. So we need to move this over. So this is x squared minus 8x plus 16 equals 0. So x equals negative b over 2a. So I get x equals 8 over 1 times 2. Okay, so that is x equals 4. So we know this is 4. If I was to plug 4 in, so 4 squared minus 8 times 4 plus 16 equals y. So that's 16 minus 32 plus 16, that gets me y. Oh, that's 0. Interesting. And on this next one, if I was to plug 0 in for the x's, that would get me 16. Okay, so here we go. We have 4, 0 in the middle. We have 3, 2, 1, 0, 16. We have 5, 6, 7, 1, 2, 3, 8 would be 16. Okay, if I plugged in 3, so 3 squared minus 8 times 3 plus 16 equals y. So 9 minus 24 plus 16 equals y. So that is going to be negative 15 plus 16. So that's 1. So that was 3. So now I'm going to plug in 2. So 2 squared minus 8 times 2 plus 16 equals y. So 4 minus 16 plus 16. So that'll be 4. And then I'm plug in 1. So 1 squared minus 8 times 1 plus 16 equals y. 1 minus 8 plus 16 equals y, so that's negative 7 plus 16. So that's 9. Okay, so if I plug this in, so 4, 0. And then I have 5, 1 and 3, 1. I have 6, 4. And I have 2, 4. And I have 7, 9. And 1, 9. And there we have it. Oh, and I just realized I haven't been drawing the axis of symmetry. There we go. Okay, next. X equals negative b over 2a. So negative b would be 1. X equals 1 over 2 times negative 2. So that gets me, what, negative 1/4? Okay. So negative 1/4, comma. So plug this in. So negative 2 times negative 1/4 squared minus negative 1/4 minus 2 equals y. So negative 2 gives me 1/16 plus 1/4 minus 2 equals y. So this gets me negative 1/8 plus 2/8 minus 16/8. So that would give us negative 17/8. Oh, really? Negative b over 2a. Okay. Negative 17/8. So that's negative 2 and 1/8. Y-intercept, plug in 0. That would get me negative 2. Zero, negative 2. Negative 1/4. I feel like I'm doing something wrong on this one. Negative b over 2a. And that would get me 1, negative 4. Okay, that's right. And then I plug in -2, this squared is 1/16, -1/8. This gives me 1/4. Oh, that's the problem. That should be 15. That's why. Okay, I figured out my problem. I knew something was awry. -1 and 7/8. That makes so much more sense. Okay, it may not make sense to you guys, but it makes sense to me. Okay, so this one is not going to be even on doing this, guys. So we're going to have to actually plug in some points. So we're going to do -3, -2, -1, 0, 1, 2, 3. Okay, so 0, -2, we have that one. Oh, I should put in the 1/4, -1, -2, -3. Okay, so if I plug this in, so -2 times 9 minus -3 minus 2. -18 plus 1, so that's -17. Then if I plug in -2, so -2 times 4 plus 2 minus 2 is going to get me -8. And if I plug in -1, so -2 times 1 plus 1 minus 2. So it'll get me -2 minus 1, so -3. We already know this is -1 and 7/8. If I plug in +1, I get -2 times 1 minus 1 minus 2. That'll get me -2 minus 3, which is -5. If I plug in 2, I get 2, 4, minus 2 minus, oops, am I doing 2? Yeah. So -8 minus 4, so this is -12. Okay, so here we go. So -2, -8. 1, 2, 3, 4, 5, 6, 7, 8. Then -1, -3. 1, 2, 3. Then 0, -2, 1, -5. 2, 3, 4, 5. And 2, -12. Okay. Now some of you are like, why is that not working? So remember, when you're doing this, the axis of symmetry is right here. So this only went over a quarter. So if I only went over a quarter, it would be right there. This went over 3/4, so this would be right here. This point right here, this one right here went over 1 1/4. So if I went over 1 1/4, that would be right here. This one right here went over 1 3/4. So if I went over 1 3/4, I would be here. So there you go. Okay. In 1941, the Boston Red Sox Ted Williams hit the highest pop fly ever recorded, assuming initial velocity of 58 meters per second, initial height of 1 meter. The function h equals -4.9 t squared plus 58t plus 1 models the height of the baseball in meters after t seconds if it falls to the ground. Approximately how long would the ball be in the air? Okay. So t equals -b/2a. So if I replace the b, that's -58, 2 times -4.9. So I actually need a calculator for that one. So 2 times 4.9 is going to get me t equals -58 over -9.8. So 58 divided by 9.8 is going to get us 5.918367,347. Okay, so if I plug that in, 5.918367,347, and I plug that into my equation. So I have -4.9 times, in parentheses, squared plus, oops, no, not times, but plus 58 times that number plus 1. I'm going to get 172.63265331. The y-intercept, remember, plug in 0, or this should be the h-intercept. 0 for all the t's, and you would get 1. So the middle one is 5.9-ish and 172.632. Okay, we know that 0 is going to be 1. Okay. Now, what do we want to go up by? Because this is 172. So I'm going to go backwards. This is going to be 5, 4, 3, 2, 1, 6, 7, 8. So I'm just going to plug it into my calculator. So -4.9 times 1 squared plus 58 times 1 plus 1. And that's going to get me 54.1. And then I'm going to plug in 2. And if you have the kind of calculator I have, all you have to do is go up and edit what you just did, and you will get 97.4. And then go up and edit and put in a 3 and get 130.9 and go up and put a 4 and get 154.6 and go in and go up and put a 5 in. and we get 168.5, and go in and put a 6 in, and get 172.6, go in and put a 7 in, and get 166.9, put an 8 in, get 151.4, put a 9 in, $126.1. Now putting a 10 in, I have to change it a little bit. There we go. There we go. So 10 got me 91. I'm purposely trying to get it down to where it's 0. 11 is 46.1. 12 is 12 is negative 8.6. So somewhere in between here, it's going to, and we have 0, 1. Okay, so the highest was 172.632. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to go up by, I want 173. I'm going to say 175 divided by, how about, I go up by 20s? Or no. Yeah, I'm going to go up by 20. 40, 60, 80, 100, 120, 140, 160, 180. So if I do this, 1, 0, or 0, 1 is way down there. And then 1, 2, 3, 4, 5, 6. So somewhere here, 172 here. 6 is going to be like right below it. 7 is 160. Oh, no. A little bit higher here. 160. 7 is 166.9. 8 is 151. So somewhere about here. 10 is 91. 11 is 46. And then somewhere here, 12 is going to be way down here. Okay, I'm going to do 3. 3 is 130. So somewhere about here. So something like this is happening. Okay, but it's going to hit before it gets to 12, somewhere before 12. So how long is that in the air? So it's in the air just less than 12 seconds. Oops.